Hello everyone, my name is Mr. M. Today we're going to learn how to verify inverse functions using composition of functions. So go ahead and complete the intro activity first. Be sure to pause your video while you're doing it. Come back once you're done to check your answer. And the answer is option 2. There you go. Now let's go to the key concept and keyword at the same time. If f of g of x is equal to x and g of f of x is equal to x, then f of x and g of x are inverses of each other. It's kind of abstract, right? Let's have a model problem so that you would understand it better. It says use composition of functions to verify if the functions below are inverses of each other. Now, it's actually two-part work. If you notice, I put down the definition in the previous slide. So we want to show that the composition of function, if we merge them in this manner, we need to come up with x. And also, the result of other composition of function is x as well. Let's see how it works. All right. Now take a look here. The letter f is outside the composition of function, right? So therefore this is your outside function, f of x, which happens to be x squared plus 5. So I copied x squared plus 5 down here, but this time I'm going to put parentheses around x and also remove the x. Why is that? Because I'm going to substitute something else. I'm going to substitute this to that. Alright? So what's the result? I'll take that off. So how would it look like? I'm going to write that down here. The square root of x minus 5. We know that the square, this exponent, and that square root symbol are inverses of each other, so they can cross out each other. So what's left? X minus 5 inside the parentheses plus 5. But can you do anything inside the parentheses? Can you simplify this further? No. So therefore, I can just remove the parentheses and then I can simplify it further. How? Because we know that negative 5 and plus 5 are opposite of each other. It's 0, right? So what's left? It's just x, which is our target. We have shown that the composition of the function is equal to x. But that's half, the first half of the work. We need to do this as well. So g of f of x is equal to x. Now, g is outside, it's the outside function. Let me clear this up. So what does it mean? I'm going to copy that, the square root of x minus 5. And then I'm going to clone that here. Then I'm going to put a parenthesis around x. Yeah? And erase it, erase the x. What do I put inside? This one. It goes there. So this will become x squared plus 5 inside the parentheses. Can we take this further? Can we simplify x squared plus 5? No, there's nothing we can do with that. So we can just simply remove the parentheses. Right? And then now we can simplify this, which is 0. Right? What's left? The square root of x squared. And again, we know that this radical symbol, the square root symbol, and this exponent too are inverses of each other, so they're gone. What's left? Just x. Right? So we just shown that the composition of this function is equal to x. What does it mean according to the key concept? That these two functions are inverses of each other. So the answer is yes. Now let's have model problem number 2. Same instruction. So again, it's a two-part work. Again, f is the outside function, so we're going to copy this, 3x plus 8. If you're visual, you can copy that again. And then put parentheses around this x, right? And erase it. What do I put inside? This 8x squared minus 3. So this line becomes 3 times 8x squared minus 3, right? Then plus 8. Since we have 3 outside, we distribute. So 3 times 8, that's 24x to the second. 3 times negative 3, that's negative 9 plus 8. Right? Equals. We simplify this. We bring this down, 24x squared minus 1. Now can we take it further? No. This is our answer. But is that the same as this? So no, it's not. It's not a single x. So what does it mean? It fails on the first half of the test. So do you have to take the second half? You don't have to. You can already say that these two functions are not inverses of each other. So the answer is no. There you have it. Now it's your turn to practice. Go ahead and complete these two problems. Be sure to pause your video while you're doing it. Come back once you're done to check your answers. And the answers are yes for the first task and no for the second task. But again, you gotta show work, okay? It's not enough that you guess, oh, this is yes, this is no. Nope. Let's have another set. Go ahead, pause your video, come back once you're done. And the answers are yes for that and no for the extra credit. Thank you for watching and learning with me. Be sure to click the links below inside the description box for additional resources so that you can practice and learn more. Please take care of yourself and each other.